Welcome you all once again. We started with assemblies yesterday, and we have seen the example that gives us little bit understanding about the assembly environment. Uh, so, as usual, we are going to have a recap. In the recap, we will see the example itself in a nutshell that we have done yesterday. So, before in the first, what we have done is we have seen the namespaces related to assemblies, and we tried to understand mainly the difference between component, assembly, and component. If you able to recall, component class has the APIs related to accessing some information about component. But component assembly has the APIs or the builders. Those are mainly relevant for assembly environment. For example, constraint, arrangement, uh, adding component. So those kind of APIs. So we started with understanding these two classes, and we have picked up this example where we are getting the position of a component. So getting something out of any object in NX, we do need to be very specific. So here, what API we do have? We have this API, get position API, and this API gives us the point and the matrix as output. But this API is only works on the component. Okay, so we have to first provide that component to this API, and to provide that input component object, we have done uh, some steps here. So first of all is that we have used this name, and we tried to create a loop in which we are trying to find out the name, uh, the given name. So we do have a loop that goes through each component one by one, and that goes through each and every component. And for each component, we are checking the name against the given name. So this is how we found out the name, the matching name, component, object, and then we are simply going and picking up the position. Now, we are going to see few more examples in assemblies in order to widen our knowledge in assembly. So let me first introduce what we are going to see today. We are going to talk about traverse. And within traverse, recursion is a very important concept that we are going to see. We have also done a traverse yesterday, that for each loop is nothing but a traverse. But there is one more important angle to traversing. What is happening? Yeah. So we are going to see the another example. But before that, uh, let's see. Okay, so this is, I think we can take a little later. So let's understand about traverse first. Traversing meaning accessing each element of a structure at least once. So we do have assembly structure, and assembly there are several components. So we are accessing each element at least once without missing any element. That is called traverse. Element in this case is a component. Let's see if I take another example. If I take example of a part, then if I want to go through all the features of a part, then the feature becomes element. And if we are using some method in our program that accesses each of those features at least once without missing anyone, that is called traversing. If our code is not accessing each element, it is not traversing. It means that, let's say, if there are 10 elements, whether it is sketch feature, whether it is a list of features in a component, sorry, in a part, whether it is all the components in an assembly, if we are missing any one element of that, then this is not called traverse, uh, because it is not matching the criteria of traversing. In case of assembly, traversing is not possible without recursion. The reason is we do have levels in assembly. We can have one top level assembly, and then within that assembly, we can have combination of assemblies and part. So if we have combination of assemblies and part, it means there will be some assemblies and there will be some parts at level 1. And then within those assemblies, we do have other components and assemblies. So it means that it is not the list. Uh, uh, it is not a list where we do have all the elements at level 1. We do have these elements which are scattered in a different level. So you can understand this by a bomb or even assembly is very easy. So we do have the levels in assembly. We do have assemblies into assembly, and then other assemblies into that assembly, and then parts. So like that it can be. So it is multi-level structure that assembly is built on. And if we wanted to access that multi-level structure of components in assembly, then we do need recursion. Traversal will not be possible without recursion. Because if I just use traverse like yesterday, then it is only going to check the components or assemblies which are at level 1. And what about the children components of assemblies inside top assembly? So we are going to miss them. And if we are going to miss them, it is not traversing. So that is why recursion is very important in assembly. Without recursion, we are not going to uh, touch upon each element in a structure. So in case of faces, edges, curves, features, etc., for each loop is enough, because each means each face it will cover. It will access each face at least once. For each itself is going to touch each element, provided all the elements are at same level. So this is not traversing is very easy in terms of faces, edges, and other items in a part level. Even expression, even let's say, I think I'm not sure, but arrangements or something else in even case of assembly, which is at same level, we can very well do the traversing with the help of for each loop. Now, let's talk about recursion. So you can imagine, or you are good enough to understand that concept. We do have assemblies with components and assemblies placed at different levels, right? So what is recursion? Let's say I do have three components in an assembly, or I do have three boxes. Now traversing is accessing each box once. So these are all at same level, at the same floor. Uh, my job is to go and check the boxes. I will check first one, then second one, then third one. So all three are checked. So all are at same level. Checking this is very easy. I can do it with for each loop. But let's say if I found a box which has other boxes placed in that box like this. Then my job is that I am only going to check the box. So first check it is empty, second check it is empty, third check it is filled. But my job ends there if it is not recursion. So in case it is not recursion, my job ends here. I will just check if it is filled or empty. That's it. I'm not going to do anything extra. But recursion means I found a box within box. So as I told that I have to check and box, I have to go and check the box. So as I found the box inside box, I am going to check the box inside this box. So bigger box. So whatever box I found even inside, I am going to check and open that and will check if it is empty or filled. So that is called recursion. So recursion is little smarter than just a for each loop. This recursion means I am going to repeat the same step that I have done uh, on the first level. So this is the floor. On this floor, I checked the first box and I checked whether it is empty or filled. I have checked. I have done the same thing for second box. For third thing, even same thing. But if I found the box inside this first box, even I am going to do the same thing which I done for the first or second box. I am going to check it whether it is filled or empty. And even if I found one more box within that box, I am going to repeat the same. It means that logic is trained to check all the boxes. And with this recursion method, I can be sure that whether there are n number of boxes on the floor and there are again n minus some number, uh, let's say x number of boxes on the floor which do have boxes inside boxes that are also going to be checked. So I am sure that if my logic is following this kind of instruction, it is going to check all the boxes irrespective of uh, whether there are boxes inside boxes inside boxes inside boxes or it is just one box which is empty. So recursion ensures that the assembly is accessed, the each component in the assembly is accessed till the last level component in assembly. So that is recursion. So how recursion happens? Before we see this, let's see the yesterday's example once more. I will try to have some other assembly because in this assembly all are at same level. All components are at same level. I will open some other assembly and till the time I need to modify this code little bit. Let me see if I can modify that code because now I do not want that code to only work with that specific name component, with that specific component name. I want that to work with anything. It's taking time. Yeah, I think I'm here. So I have found a root component. Then what I will do is I want to now modify the code. I will copy this line just after root component. I will paste this for each loop and then uh, this is a root component. So I need to change the variable name here. It remains the same. Then I don't need this if condition, because now I am making it simple. I'm just going to uh, access each component in assembly, and I just wanted to print the name of component or display the name of component. So what I can do is that I can use this this line guide dot info write line dot uh, uh, comp1 dot name. I think I will use display name. Okay, I don't need to use return because now I'm not using a function like this, and I don't need this even. I only need for each loop. I don't need this even. This is not required. These all things are not required. Okay. So once I got the root component, the top level assembly itself, for each loop is finding out all the children of that root component, the top level assembly. And for each of that component, we are displaying the name. So this is what is happening here. So I will copy this code. We'll get into new journal and paste it again. And I will try to run this journal. Now I do have this assembly. Excel assembly is going to be the assembly, and wheel part, engine part are two parts that I do have. So if my uh, assembly level is 1, car assembly, the top assembly level is 1, then Excel assembly, wheel part and wheel 2 are level 2. I have got these 4 items: engine part, wheel part, and Excel assembly 2 times. The reason is Excel assembly, two instances are used. So I was talking about car assembly being level 1, Excel assembly, wheel part and engine part being level 2, and then wheel part, which is level 3. So now what happened? My code has ignored this wheel part, right? Because I was using a simple thing only for each loop without recursion, and for each loop don't know if there is an assembly it has to get inside. That for each loop don't know that. For each loop don't know recursion. That's why that for each loop is not enough to traverse the entire assembly. Maybe you might have a large assemblies where you do have the components till level 8, 9, 10, or even more, and you have only few assemblies at level 1. But with this code, with this piece of code, it will only fetch the names of level 1 components, whether it is assembly or whether it is part. It will only fetch the level 1 components. Now this is what we have missed, and in order to pick up all the children of all the assemblies till the last level in the assembly, we do need the recursion. Now we are going to write the code for recursion, and it is recursion is though very difficult to understand, it is very simple to implement. Most of the times you might have experienced that the concept is easy to understand theoretically, but to write that thing in terms of programming, in terms of a code, then it is difficult. But in case of recursion, it is vice versa. Understanding recursion might be a difficult. Gaining what is the concept of recursion might be difficult to digest if you heard this first time. But implementing recursion is very easy. Now we are going to see the theoretical implementation of recursion. So let's say we do have a function A, and what that function A is doing, there is a for each loop in that function, and that for each loop checks all the components one by one. The same way we do have a for loop which is checking all components one by one at that level. We are using get children into this for each loop. Now there is a if condition. After that, after the for each loop, there is if condition. The if condition is if component name, we are checking the component name. If sorry, not component name, we are not checking the name. We are checking if that component is assembly. If the assembly is found, then we call this function once again. Actually, we call this function here itself. So what we are doing, we are calling the function inside the function itself. And then our for each loop goes to next iteration. So this we are doing before our for each loop ends. So before for each loop ends, we are calling the same function again. Now, now pick up that example again. So once I got the box, my task is to check if the box is filled or empty. So that is function A. Now, if I move to next box, it means next iteration, then I found the box inside. So my first check is that if there is a box inside, I'm checking whether it is filled or not, but at the same time, I'm also checking if there is a box inside. Then if the box is found, then what I'm doing, I'm repeating the same task. I'm checking if it is filled or empty. And that is our function A. So I am repeating the function A in the function A itself if the condition matches. If I found the box inside box, I am going to check if it is empty or filled. If I get inside that box and found another box, then I'm going to repeat the same process. It means that I am repeating the same thing again and again till the point I keep on getting the box. So in short, in summary, calling the function inside the function itself is recursion. Now let's see this with an example. This journal, this journal is a traversing, and here we are not using a function. Here it is just a for each loop. This one only for each loop. So this can called uh, traverse without recursion. Now I want to write a recursion. So let's do that. We'll modify the same code actually, and we are going to do that. Let me pick up the reference for my inputs. Okay, so what I am going to do, I am going to do I'm going to write a function. So here I will write a function. After this root component, I will write a function, or here actually I am going to call that function. But now we'll just complete this main function here itself by closing this bracket, and I will write another function, static void get component name. This is the name of this function, and inside this I will declare a component as comp. So here, if you notice, static void, I have not mentioned any object type. I have straight away mentioned the name of function. It means this is a kind of function that will not return anything. So if I do have mentioned anything here, it is going to return that object type. But here it is, I don't know, I don't require the function that returns the object type. Okay, these curly brackets to ensure the scope of this function. Now I will copy this for each loop and will paste that inside this function. And I do have this line which gives the name of a component. Now what I want to do before my for each loop gets into next iteration, I want to call the same function, and then within this what I will do is I will provide the name of the variable which I have used in a for each loop, and then semicolon. So this specific line, what I have written, what I have done is get component name is a function that uh, I have done something wrong. This is the start of a function. This is the end of a function. So this is a function. The function name is get component name. And if you see, I have called the same function within this function. So this is what ensures recursion. And I want to call it in the main as well because I have to provide the entry point for this function, right? This is at the moment it is outside main function. What will happen in a usual case? The initial code is going to be executed from main function. It will execute these lines and it will end here. This will not be covered. Even if I have written this function in this CS file itself, but there is no entry point provided. There is no execution point provided. So I have to provide the execution point, which is like this only. I have to copy this line and have it here. But here there is no variable as component one because this is the boundary of this main function and there is no variable with comp1 in this. So what we have is we have top assembly component. Okay, so this is the object we are giving input to this function. But when this comes here, we do have different name. We do have comp as a name of the top assembly. So I need to use comp.getChildren inside for each loop. I will talk about this little more. Uh, let me first let me first focus on the recursion. Okay, so here I have given the trigger point for this function. Once I get into this function, I do have a for each loop and I do have a recursion uh, by calling the same function within the function. Now, if I execute this on the same assembly, let's see what happens. We do have these 4 lines displayed here uh, because of the earlier journal that we had. Now, after these 4 lines, whatever you see here, it is because of the new modified code that we had. And you can notice uh, it started with engine part. The sequence is not as exactly the same, but we can take care of the hierarchy. Then wheel part, then axle assembly, and you can see within axle assembly we do have 2 instances of wheel part. So those are captured. Again, here in axle assembly, these 2 are captured. Okay, so this is because of recursion. This is just because of that one line. Now, if I go and comment this line, I am not now calling the function within the function. If I comment this, let's see what is the result. You can see the result is same as earlier code. We do only get the top level components and our code has missed touching upon the components at the level 2 or 3. Okay, so this has happened because of recursion. And now let's see uh, some more uh, some more explanation about the functions that I have used here. So this line is actually uh, we are calling the function. So function name is get component name, and similar to any API, we know that in API there is something called constructor. It means there are some parameters we mention in the bracket and we have to mention them as expected by that API. So similarly for function, we can also have some parameters within the bracket. So, and why that parameter is required? Because let's say if we wanted to do something in that function and the input reference required for that function is available outside that function. Now better I will copy this entire code into a Visual Studio. That will be easier for understanding point of view. Okay, so you can see now you can see my cursor. This is the start of bracket. This is the end of bracket. It means this is the scope of main function. Now within main function, we do have the session, we do have work part, we do have component assembly, we do have top assembly component. So these objects we do have along with their values. So we do have objects inside these variables even. Now, in order to traverse the entire assembly, I need to use getChildren API, right? And I can use getChildren API on a component. You can find that information in IntelliSense even. So component should be a top level component, because if I start with any other component in assembly, I won't get all the components. So obvious thing is that I shall start from top level component. It means the assembly itself. So if I use get children on top level assembly, I will get all the children components which are at level 1. So in order to traverse, I need to use get children. And for using get children, I need the object of top assembly. So uh, uh, and the next is I am going to use this get children in the other function. The function name is get component name. So I'm going to use that get children API within this function, and the boundary for this function is within these two brackets. So as I need that component top level component object, I have used that object in the bracket itself. If I need two input parameters to work on in this function, I will define those in the bracket. If I need 3 parameters, 4 parameters, 5 parameters, I will go and define them one by one. Remember the earlier example. In earlier example, we require 2 parameters because we want to compare the name. That one parameter to get the children, the other parameter is the component name itself for a comparison. So that's why we do have 2 parameters inside the bracket for the function. Here I don't need to compare, so I only need the one parameter, which is top level component, for getting the children components of that. So that's why we have passed this variable name inside this function. Now about this function is declared like this, and as this function requires a parameter, I have to define, not just define, actually I have to declare that parameter. The parameter type is, the variable type is component, because you can see the assembly component variable, the type is component only, and the same component is defined here, only the name is different, because this is the boundary of main function, and this name is relevant in this function, top assembly com. But this is the different one, different function. It means it will be a different component, uh, a different variable name. Now you will say this is just a component, but this is nxopen.assemblies.component. It doesn't matter. I can even copy the same here like this, or even I can delete this entire nxopen.assemblies from both the lines, because I do have mentioned nxopen.assemblies on top. So my code understands what is meant by component. It understands that it is from nxopen.assemblies. So that is not that uh, there is no difference actually if I use nxopen.assemblies.component or if I use just a component. So the same object means the same object name is comp in this case, but it will have the same object value, means the value, uh, the object which is assigned to this variable will be same, the top level assembly. And then once I have it, then I can use it in my for each loop like this, comp dot get children. Okay, and this line, this particular line, and this line are same. The only difference is here I am checking the children of a component found in for each loop. In first attempt, I started from the top level assembly. But let's say in top level assembly, we do have 4 components that comprises of assemblies as well as components. The same case that we have in that assembly. So it means that my for each loop will go through 4 iterations because there are 4 components. And I want to check the children of all the 4 items. And how I go and check that? Using recursion, because get children API is already used in this function. So if I recall this function, I am anyway going to check the children of a of a component which is found in the iteration. So first component, then second component, then third, and then fourth. Because at least this for each loop is going to ensure that it is going through all those 4 components one by one. So it means that I am anyway checking all those components, 4 components, and this line ensures that I am checking the children of each of them, whether it is component, whether it is assembly. If I found children, I am going to get inside and check access the names of all those components one by one. So this is what is happening here. I think this is uh, much more when it comes to the explanation of uh, this journal. Now let's do debug here to understand more. So I will save this journal and I am going to run this journal in a debug mode. I will put my breakpoint. I will rebuild this code. I have to see that it is rebuilt successfully. Because if rebuild is not successful, if DLL is not created, we cannot run it in the debug mode. My system seems slow today for some reason. I don't know. It's taking too much for a small thing even. Remember, we do have 4 components at level 1. Out of that, 1 is assembly and 3 are components. Still working. This is strange. Yeah, so rebuild all success. That is fine. Now I will attach to a process. Hopefully it will be faster, but still I doubt that. Each function has a boundary. Each function is separate from each other. So maybe we do have several functions in one one journal or one program, but all of the functions are different from each other. And the scope of what we can say, the scope of variable is limited to that function. Otherwise, it is a public function. The scope is limited within that function, and that's why we use different variables. We define different variables for the same object type in different functions. It is attached. Now I will go and execute this in NX. It is taking much more than expected. Actually, I don't know how to deal with this in between the live session. So I have to bear with this. Mm, I have to see the location of this project. File execute. I have to get into bin debug and class library one.dll. Okay, so I have started the execution. Yeah, now I entered into debug mode. Okay, so what I will do is I will check the variable value for the work part. Ignore the spelling mistake here. Okay, we do have some object at least because it says part and some number. So we do have some object. Now for component assembly even you can see we do have some object for this variable. Now let's see this top assembly component. Top assembly component even we do have some object. Now if I expand this, now I can see the display name is car assembly. It means that this is the assembly name itself, the top level assembly name itself. So I have picked up the top level component correctly. So that is fine. Now I'm calling this function. So we do have this top level assembly object in this variable. So I will press F11. So if I press F11, it means for F8 and actually F8 and F11 is same. Step into it means it is going uh, to execute the code line by line, one line each time. So we got into this function. Now see this comp variable. So this comp also is car assembly, because though there is a difference between name of the variables, but the object that is assigned to both of these is same. This only the difference in name. Otherwise, it is same because it is same function and only same variable type uh, there in the bracket. Okay, so that is why though it is different name, but the object is same. Object is car assembly component only. Okay, now I get into for each. Now get children is used on component, which is car assembly, top level assembly, and get children means actually it returns all the components. So it returns the arrays of component. It returns the collection of components. So in this case, it is 4 components it will return. Now for each means for each of those 4 one by one. Now one by one means in first iteration you can see we do have comp1 as null now. But when this code in yellow will be executed, we will have an object in component. Now you can see it is component some number. It means we do have got object. That object is the component engine part. So this is the first item of all those 4. Now what we are doing, we are displaying the name of that component. That is done. Now I am calling the function again. So what will happen after this line? I am calling this function using engine part as a component. Now this time it is engine part. When we have started first time, it was the top level component, which is car assembly. But now it is one of those 4 components. So as I recalled this function here, you can see from here my code directly jumped to the startup function. Now startup function means it will again start with for each loop, but this time it will start with first item out of those 4. Engine part is the item, is the component. So for that one, we are going to have the another for each loop. Comp is engine part, and I am going to check the children of it. But as it is the component and it is not an assembly, there are no children found. And that's why you can see after this API, my code directly jumped to the end of this function. These 2 lines are not executed because simple is there are no components inside. So the first item out of those 4, which is a component, we have checked the children of those components, and our API found that there are 0 components. And as there are 0 components, there is no meaning of for each. So it directly went to the end of function. Then now next is we have jumped from here to here last time. So now our code will resume from that point. So it is resumed from that point and it is going to start on the iteration number 2 out of 4. So first iteration is finished here. You can say this is for each, this is start of for each loop, this is end of for each loop. So we are at end of first iteration. Now we will go into next iteration, second iteration. And in this second iteration, we will pick up the next thing. We have picked up engine part first. Now we have picked up wheel part, which is the next component in the iteration. And the same thing for it, we will check components. And I think we will not find any components now because it is another component. It is not an assembly. You can see not found anything in this API. Zero components found. So it has come to the end of the function. Now it is resuming from this. Now this is going to be the third iteration. And in third iteration, it will become the third component. Third component is Excel assembly. And it is an assembly, and we are going to find something here. So we are going to find, so this iteration recursion is triggered and for each loop. So now this is the third iteration of the first for each loop, and we got into the finding the components of assembly, Excel assembly. And this time we will not return to this point, the end of function, because we will get some children. And as children components are found, now it has got into the another level of iteration, the next level of iteration. It is not next iteration actually, it is the one level inside. And we have found the first component within Excel assembly, which is wheel part. So this is how our recursion triggered getting into the next level in the assembly. Okay, and then it will continue based on whatever levels of components and assemblies we do have in our assembly. So it will continue till that last uh, component object in our assembly. That's it. And we got this as a outcome. All the elements are accessed and information, the display name of all those components is fetched without missing anything. So this is called recursion. And I think it landed very well to all of you now because we tried to I tried to explain you in every aspect that I can about recursion. And maybe I don't sure I'm not sure if I told you this yesterday. Traversing with recursion is very crucial for assemblies because otherwise the APIs, the classes, and fetching information or other builders part is more or less common. But if you know the traversing part, then you know uh, how to deal with the assembly. So that's why it is important topic.